So we are going to be working on cross sections. The equations that are given is y equals negative x squared plus 4 and y equals 0. So here is the parabola with the intersection being 0, 4. We are given that the cross section is perpendicular to the y axis, which is that section right there, and that we are working with a semicircle cross section. And in this case, or in all cases, this line here is the base of this cross section. So the equation for this line will equal this line, and we are first going to try to find the area of this section, because in order to find the volume, we have the integral from a to b with the area of your cross section, and in this case dy, because pointing to, so in this case it's pointing to the y-axis, so we'll be using y values. So that's why we put dy rather than dx.
So we want to find the area of the semicircle at any given value, and the formula for the area is 1/2 pi r squared. R is 1/2 of the diameter, so you can see the equation r equals, and to find the diameter we find the length of the rectangle. In this case, because it's a dy, we subtract the leftmost curve from the rightmost curve. We're finding this in the first quadrant, so our leftmost curve is x equals 0 and our rightmost curve is y equals negative x squared plus 4. We need to change the second formula into terms of y, as you can see off to the side. Once you find the equation for r, you sub this back into the area equation and then plug that back in to the volume equation as your final area, all in terms of y.
So we are now given the integral. Now, since 1/2 and pi are both constants, to make it easier, we can take them and place them on the outside of the integral because they won't be affected. And then, since we also have 1/2, and that's also a constant in this equation, we can also place that on the outside of the integral, making this 1/4. And then in here, we'll put the square root of negative y plus 4 squared dy. And then for a and b, since we're using y values, we need to find the two endpoints in which we're looking for the volume. So in this case, since y equals 0 is the bottom line, our endpoint is at 0, 0. So the y value for that is 0, and our top value here is 0, 4. So our top value would be 4. Or pi integral 4, 0 square root of negative y plus 4 squared dy, and this is your answer. Okay, next we are going to be doing the disk method, and we're going to start off with an example problem with the area is going to be bounded by y equals x plus 1, y equals 1, and x equals 3. X equals 3 is also going to be our axis of rotation, so that will make us have a horizontal rotation. So we're going to have to change y equals x plus 1 to x equals y minus 1. And that's because it is dy. And then it is called the disk method because in this specific problem we have a cone, because if you rotated it around the axis, you would get a cone if you could imagine the triangle going over all around. but if you take one cross section from the cone, you would get a disc because there is no hole. That is for the washer method, which we will talk about later. And so in this specific problem, for disc, the original formula is volume equals pi from the integral a to b, r squared, and in this specific problem it is dy, but it could also be dx. Now we're going to find the values of a and b, and for this specific problem it is going to be 1 to 4 because our lowest y value is 1 and then our highest is 4. And we're going from right to left since it's dy, not dx. And so our right boundary is x equals 3, so it's going to be 3. And then our left boundary is x plus 1, but we changed it from x plus 1 to y minus 1 in terms of dy. So it is going to be 3 minus y minus 1 squared dy.
So for our washer problem, we're using the same curves as we did for the disc method. So we have y equals x plus 1, y equals 1, and x equals 3. So we have the same region bounded by these curves. But for the washer problem, we're going to use the x-axis as our axis of rotation, which means our rectangles will be vertical. This makes it a dx problem. The reason it's a washer instead of a disc is because we have the space between the area bounded by it and the axis of rotation. So when we rotate just the single rectangle, we end up with this shape. This is our rectangle, and it becomes a washer because there is a hole in the middle. So when we rotate the entire thing, it's not a cone, but it's this shape with a hollow center because we have the space between. So the general formula for a washer method with dx is volume equals pi from the integral a to b with the big radius squared minus little radius squared, and this one is dx. So the big radius is the topmost curve of our region all the way down to the axis of rotation, and then the little radius is the bottommost curve all the way down to our axis of rotation, and the reason it's top minus bottom is because our rectangle is vertical, so it's dx. So for this specific problem, we go from y equals x plus 1 all the way down to y equals 0. So that is our big radius, and then y equals 1 down to y equals 0, that's our little radius. So we sub both of those into this formula up here as big R and little r, and our limits of integration need to be x values because we're using dx. So our smallest x value is 0, and our biggest x value is 3, so those are what we put in for a to b, and this is our answer.